Hello, this is Ray, one of the program presenters in the Atchison Planetarium at Cranbrook Institute of Science, with a look at the pre-dawn sky for the week of June 29th. 3 planets are visible at 4 a.m. Eastern Daylight Time. Mars is in the southeast. Jupiter and Saturn are in the south-southwest. Jupiter is the brighter of the two. Jupiter and Saturn are in a location where they also can be seen just rising in the east-southeast after 11 p.m. We'll have to wait until 5 a.m. to look for Venus. It'll be in the east-northeast in the glow of morning twilight. There will be 2 good opportunities to spot the International Space Station this week. The first is on Tuesday morning. The ISS will appear about 10 degrees above the west-southwest horizon at 5:06 a.m. It'll be 67 degrees above the north horizon at its highest, and will disappear about 40 degrees above the northeast horizon. The period of visibility will be about 4 minutes. Be advised that the sky will be getting brighter because of morning twilight. The second opportunity is Wednesday morning, July 1st. The ISS will appear about 35 degrees above the southwest horizon at 4:20. It'll be 74 degrees above the southeast horizon at its highest. At this point, it'll be passing through the legs of Pegasus, the flying horse. Remember the great square that formed a baseball game? The ISS will pass behind home plate. The ISS will disappear about 25 degrees above the east-northeast horizon. The period of visibility will be about 3 minutes. We're 9 days into summer now, with summertime temperatures, and it may be a surprise to know that Earth is at its farthest from the Sun at this time of the year. That officially occurs at 7:34 a.m. Eastern Daylight Time on July 4th. But why isn't the Earth at the same distance from the Sun all year long? It's because Earth's orbit isn't perfectly circular. None of the planets in our solar system have circular orbits. All the orbits are elliptical or oval, and they're a little off-center. That being the case, there's a point where a planet is closest to the Sun, which is called perihelion, and a point where it's farthest away, which is aphelion. Earth's orbit is relatively circular. Our distance from the Sun varies by only 3 million miles, or 5 million kilometers. The planet with one of the most elliptical orbits is Mars. Its distance to the Sun varies by about 26 million miles, or 42 million kilometers. The least elliptical is Venus at about 1.25 million miles, or 2 million kilometers. Rounding out the solid planets is Mercury, with a difference of 15 million miles, or 24 million kilometers. So if Earth is farthest from the Sun in July, when is it at its closest? Well, believe it or not, it's closest in winter, around January 4th. Now, why do we have the hottest weather when we're farthest from the Sun and the coldest when we're closest? It's because the distance to the Sun has a negligible effect on our temperature. Remember, the summer began in the Northern Hemisphere on the 20th. In June, the Northern Hemisphere was tilted its most toward the Sun, and we're bathed with the most direct sunlight. That causes Earth's temperature to increase. In January, the Northern Hemisphere tilts away from the Sun. The light we receive is indirect and the temperature cools. And does it ever? If it weren't for the tilt, we wouldn't go from summertime highs in the 90s in Fahrenheit, that's 30s in Celsius, to sub-zero in winter. Something else that will occur on July 4th this year is an eclipse of the moon. The good news is it's visible from our area. The bad news is this is a penumbral eclipse. Penumbral eclipses are scarcely noticeable because the moon doesn't pass through the darkest part of Earth's shadow. The darkest part is called the umbra. In order for a lunar eclipse to be visible to the naked eye, the moon has to pass through the dark umbra. If the moon passes totally through the umbra, the eclipse is total. If only a part of the moon is in the umbra, the eclipse is partial. The penumbra is the lighter part of the Earth's shadow. With a penumbral eclipse, the moon doesn't darken enough to make much of a difference. For what it's worth, The eclipse begins in the Detroit area on July 4th at 11:07 p.m. Eastern Daylight Time. The midpoint of the eclipse is at 12:30 a.m. on July 5th, and the eclipse ends at 1:52 a.m. The next total eclipse of the moon visible from Michigan will be May 15 to 16, 2022. So mark your calendars now. There are other eclipses in the meantime. They're just not visible from our area. There will be a total eclipse on May 26, 2021, but our area will see it as a partial eclipse. Sunrise on the 29th is at 5:59 a.m. Eastern Daylight Time. At the end of the week, July 4th, sunrise is at 6:01. Thanks for visiting and keep looking up.